Hi guys, let's extend the topic of domain and range and work on certain questions so that we get to know how to figure out domain and range for a particular question in different kind of cases. So I'm going to start with a question here. fx is equal to square root of minus 1 upon x plus 1. So essentially, if you have a function which is equal to square root of minus 1 upon x plus 1, you can just take the LCM and take the form minus 1 plus x whole thing upon x, right? You can write it down like this. So let's find out first of all the domain for this function, and then we will move on to range for this function. So what will be the domain for this function? For that we need the condition for a square root has to get satisfied. You cannot take square root of any negative number. So which means whatever is inside the square root has to be something positive. So that means whatever is here, this has to be greater than or equal to 0. Wherein again you have to be careful with the denominator. So there are two situations here you have to consider. Number one, it's a square root. So whatever is inside has to be more than 0 or equal to 0. But therein you have a fraction form or you have a quotient form. You have numerator and denominator, and your denominator cannot be equal to 0. So keep that in your mind. So that means what we have condition that x minus 1 upon x should be greater than or equal to 0. Now, this is numerator upon denominator. This is a form, fraction form. You have numerator upon denominator, and your denominator cannot be equal to 0. But the first thing that you need to be careful with is when is this number, numerator upon denominator, greater than or equal to 0? That's only possible when either both are positive or both are negative. So you get two situations here, either or. Either x minus 1 is greater than or equal to 0, or let me just explain it a bit more. So either your numerator is greater than or equal to 0 and denominator is strictly greater than 0 because denominator cannot be equal to 0. Or else numerator is less than or equal to 0 and at the same time denominator is strictly less than 0 because again denominator cannot be equal to 0. So which means that now if we write down the values, let's just give the values to it. So x minus 1 greater than or equal to 0. At the same time x strictly greater than 0, or simultaneously you have the case x minus 1 less than or equal to 0 and x strictly less than 0. Now, this means x greater than or equal to 1 and x strictly greater than 0 at the same time, and this means x less than or equal to 1 and x less than 0 at the same time. So this essentially means that what kind of numbers will satisfy that the number is more than or equal to 1, and it's also greater than 0. All the numbers which are more than or equal to 1 will satisfy automatically that more than 0, right? So what you get from here is x is greater than or equal to 1. And what kind of numbers will satisfy that they're less than or equal to 1 and they're lesser than 0? So if you take any number which is strictly less than 0, it will automatically be less than or equal to 1. So what comes out common from here is x less than 0. Now since you have either this or this, you have either the numbers which are less than 0 or the numbers which are more than or equal to 1. That means we're talking about union here. So in total, when you combine these two things, so this becomes your interval minus infinity till 0, excluding 0 because it cannot be equal to 0. Union 1 to infinity, wherein 1 is very well included. Okay, 1 is included. So this will be the domain for this particular function. Now having known the domain, let's just find out what the range of this function would be. Range, as I explain it, it is the value fx that it could take. Okay, so all the possible fx's, it's a set of all images. So let's just find out the range for this function. For that, let me write y equals to fx, that is, it is equal to square root of x minus 1 upon x. Which surely, with my logic, we can say that, this will be greater than or equal to 0, because whatever comes out of a square root is a positive number. So I know that it is greater than or equal to 0. In particular, can we say anything? In particular, what are the values of fx, or what are the different values that fx can take? Okay, so what we can do, there are two things that we can do. Now, this is clearly a differentiable function. Okay, the moment I see square root here, it's a differentiable function. So I'm just gonna differentiate it. So f dash x will be 1 upon 2 root x minus 1 upon x. Story doesn't end here. You'll have to use chain rule. So it's gonna be x minus 1 minus x, or not 1 minus x, sorry, it is x minus 1 whole thing upon x square using the quotient rule. So x cancels, and what you get 1 upon 2 x square root of x minus 1 upon x. Clearly it is greater than 0 in this domain, in the particular domain, in this domain. Because x square is positive and square root is positive, so it will be greater than 0. So which means that if the derivative is greater than 0, that tells you something about the function. It basically means that this function is, f is increasing in nature. So the nature of this function is that f is actually an increasing function. If f is an increasing function, that means it will keep on taking bigger values. The value of fx will keep on increasing. Now, what I see here is that when x is tending towards 0, x is never equal to 0, but when it is tending towards 0, then actually fx would be tending towards infinity, right? So when x would be moving towards 0, then fx would be moving towards infinity, and when x is equal to 1, fx would actually be equal to 0. Fx will actually be equal to 0. Now, whatever domain we have, in that it's an increasing function, and we can see that infinity, of course, is the biggest value that it can actually get, and x equals to 1. Actually, what you can do is x equal to 1 is again an important point here, because that's a break point here. So x equal to 1, 0, these are important points because some changes are happening in this at these values of x. Some changes are happening to the function, and that is what you would realize. You already know that this is greater than or equal to 0. You have figured out that you are attaining 0. This function is attaining 0 at x equal to 1, and then the values, because it's an increasing function, the values would keep on increasing. So since you cannot have negative values, the least value this function can have is 0, which you are attaining at 1, and then the values will keep on moving towards infinity. Okay, so yes, the range, indeed, what our logic said, that whatever comes out of a square root is positive, is indeed very much true for this function. You are getting all the values from 0 to infinity, and this is also symbolically written as r plus. R plus includes 0, and that's what the range would be. It would include 0. Now with this, let's also take another question. Let's try to find out the range and domain for the function y equals to square root 4 minus x square. So I've again taken a square root function. Now y equals to square root of 4 minus x square. So for domain, the restriction that I will have is whatever is inside has to be positive. And this time we don't have a fractional form. So whatever we have inside, 4 minus x square should be greater than or equal to 0. So that means x square should be less than or equal to 4. And that can only happen for all the x's that are in between minus 2 to 2. So what is the domain? The domain clearly is the closed interval minus 2 to 2. Closed interval minus 2 to 2. Now let's talk about the range. Range for this function. Now again, since fx is 4 minus x square, it's greater than or equal to 0. So whatever fx that would come out will be greater than or equal to 0 for sure, right? Again, you can analyze the function further. Since it's a differentiable case, again you can analyze and you would see that this function is less than or equal to 0. So the derivative of f is 1 upon 2 root 4 minus x square into chain rule gives you minus 2 times x. Now the domain is closed minus 2 to 2, which means I have negative numbers also and positive numbers also. So which means that f dash x will be, when you will put in the negative numbers, it will be greater than 0 for all x which are less than 0, and f dash x will be less than 0 for all x which is greater than 0, which means that this function f is first increasing in minus 2 to 0, and it's decreasing in 0 to 2. And f dash x clearly is equal to 0 when x is equal to 0, which basically means that x equal to 0 is a stationary point. Which means that x equal to 0 is actually a stationary point for this function. Now, since you have a function which is in closed interval, it's a continuous function in closed interval minus 2 to 2, that means that it will attain both maximum as well as minimum. Okay, so the minimum value clearly f of 0 is equal to square root of 4, which is 2, and f of plus or minus 2, that is your endpoints, that is equal to 0. So clearly what you get the minimum value at plus and minus 2 and the maximum value at x equal to 0. So which means the value the fx can take, value that fx is taking is always between 0 and 2, because 0 is the minimum value that f can take and 2 is the maximum value that f can take. Rest all other x's will give you different values, but between this range. So with this question, please also understand that if it's a square root function, you know that you will have values which are greater than or equal to 0, but you can have some particular answer as well. So with this question, you should understand that not necessarily always r plus will be the answer like in the previous question. Here, what the concept for range that I am applying here is that range of f is basically all the values that the function f can take in a particular domain from the minimum value to the maximum value. So the concept of range is basically telling you all the possible values that f can take, which basically means the minimum value of f till the maximum value of f. So this will be the range for the given function.